Okay, so let's see if this graph is a function. Does this vertical line ever touch the graph more than one place at a time?
T- They touch a lot, like the graph itself, like the physical graph, like the x and y axis.
The blue graph.
Oh, okay, yes.
So that's right. So, oh, that's the wrong color. Let's see. So yes, any vertical line that we draw touches the graph one time only. So this blue graph, which is a parabola, so this is a function. Only functions can be one to one. So let's just see. Here's my horizontal line. Is there any time that a horizontal line touches this graph more than one time at a time?
Yes, ma'am.
Yeah, absolutely. Not one to one. And one to one just means each X gives a unique Y and each Y gives a unique X that you can go back and forth. I need to text my partner. I, I can't get up and let automate. Okay. Sorry about that. So let's look at another graph. Is this graph a function? If I trace a vertical line across, do I ever touch the graph more than one time?
Yes, ma'am.
Yeah, exactly right. So,
Once, yeah, once on right below the x-axis, and then once on the x-axis.
yes, so this blue graph, can y'all hear my cat? Hi, Autumn. So this is a function. Is this function one to one? So let's take a horizontal line. How many times are we cutting the graph?
How many times are we cutting it?
Well, touching it.
Touching. I thought okay. Let's see.
And this is
Oh
supposed to
yeah,
be
I guess it is.
slightly curved up.
I'm trying to say, well, if it's a function, that means it's only touching once.
Yes.
So,
So
yeah, so
even here, where it looks like the graph levels out, it's not quite level. So we have only one crossing, only one crossing, only one crossing. And so this function is 1-to-1. So vertical lines for functions and horizontal lines for 1-to-1. And let's look at a particular function and see if there's an algebraic way to show that it is 1-to-1. So let's let f of x be 3x minus 7. We know that this is a line. What is the slope?
I believe the slope is -7.
Almost.
Oh wait, no. 3 over
Yes. And the y-intercept is
-7.
0, -7. Yes. Good. So this is a line, and we know that it is a function because it has an x. Only vertical lines are not functions. And vertical lines have undefined slope. This has a slope, so it's a function. And let's let A and B be in the domain of f. Let A and B be in the domain of f. We want to see, I've got 3x minus 7, 3x minus 7. If I put A in one of them and B in the other one instead of x, and I want to try to solve for A, if the final answer is A equals B, then the function is 1-to-1. So you take the function, you take two copies of it, you put one element in one of them and another element, and then solve for the first one. What can we do to solve for A? Can we add something to both sides? Yeah, if we just add 7 to both sides, then we get 3A is equal to 3B. How can we get A by itself?
Subtract 3 from both sides, man.
Do we subtract? Is 3 added to A?
Sorry, divide on both sides.
Okay, good, very good. So we're going to divide by 3. We have to do it on both sides. And on the left side, we just have A. And on the right side, we have B and then equals. if two elements equal each other, then the thing that sent them there, they have to be equal also. So let's look at one that doesn't work. And it's our old friend, the parabola. Let's let f of x be x squared. And a and b in the domain of f. So we've got, let's see. A, B. And they're both squared. What can I do to undo the squaring?
Take the square root.
Good. When we take the square root of both sides of an equation, we have to put in a sign. What is that sign?
Positive, negative.
Very good. Very good. Okay, well, let's just look at the left side. The square root of a squared is do squaring and square roots cancel?
Yes, ma'am.
Okay, great. And squaring and square roots cancel again. But they don't have to be equal. For instance, a could be -2 and b could be 2. What is f of -2 if f of x is x squared? In other words, what is -2 squared?
I'm sorry, say it one more time.
4.
Yes, 4. Good. I said, what is -2 squared? So negative times a negative is positive. 2 times 2 is 4. Okay. And what do we get if we play that same game with b? What is
2b.
f of
4.
Yes, that's right. So two different elements, -2 and +2, give the same y value. And that's what we don't want. A thing that we can do, let's go back to this picture. We had this lovely parabola, which is just any general x squared function. If we put a domain restriction on the function, and most of the time we start at the vertex and go to the right. So if we pretend that the left arm is not there, let's say that the vertex, well, let's just use Vx, Vy for the vertex. Then this domain restriction would be We start at the X value in the vertex, and we go to infinity. And that cuts the parabola in half. Then what's left is well behaved. And there are so many functions that we want to be able to use that are not natively one-to-one, that this domain restriction idea is very, very important. Does it kind of make sense?
Yeah.
Yes.
Groovy. Oh, let me answer this student mucho quickly. All right, let's look at one other graph. And this is, again, going to be a function. Do you see that a vertical line only touches it once? But what about a horizontal line? Does it fail the horizontal line test?
Like 3 times.
Yes, exactly. But this is the general repeating function. This is a sinusoidal function, which is the basis for almost all the machinery that we have. So we've got to be able to use it. And what we do is we start at the highest point and go to the lowest point so that our domain restriction is just these X values. And now we get every single possible Y value and an abbreviated look at the X values. And I'm going to stop the recording. Help me remember to start it back again.